Good afternoon to one and all. Just wanted to know whether the voice is clear so that we can start without wasting time. Am I audible? Please do comment it in the comment section that whether the voice is clear. Okay, fine. So today we will be discussing some of the important MCQs of the chapter Light, whether they had been the part of your practical uh, sessions or the normal one. So you will be getting the limited time in which you need to answer the question asked in the chat box. So here we start. The very first question is that the focal length of plane mirror is. So you need to answer among the four options. And here your time starts. What is the focal length of the plane mirror? At infinity, 0, negative, or none of these? Okay, fine. So if we discuss about the focal length of the plane mirror, how we will be getting to know this? See, if we talk about the plane mirror, the image which is formed in the plane mirror, basically, if we talk about the plane mirror is the spherical mirror of infinite radius of curvature. Means उसकी कोई रेडियस ऑफ कर्वेचर की लेंथ नहीं होती, इनफाइनाइट लेंथ होती है और इनफाइनाइट रेडियस ऑफ कर्वेचर होता है एक प्लेन मिरर का. And if we talk about the focal length is half of the radius of curvature. So if the radius of curvature is infinity upon 2, that is again infinity. Remember, so if we are talking about the focal length of the plane mirror, it is at infinity. Perfect. Moving ahead to the next one. Image formed by plane mirror is. So if we are talking about the image formed by the plane mirror, first it is real and erect, second is it is virtual and erect, third whether it is real and inverted, or fourth it is virtual and erect. Out of these four options, what is the characteristic of image you find in the plane mirror? Hurry up. If you see your image in the plane mirror, what would be the observation? So yes, moving ahead to the solution. If we talk about the answer, if we see the image in the plane mirror, you'll get to know by looking at this image. See, always the image formed in the plane mirror is virtual and erect. And how do we get to know? See, real and inverted basically means, inverted means the top will come to the bottom. Inverted का मतलब होता है उल्टा दिखना. तो आप एक बात बताइए, जब हम अपने आप को मिरर में ऑब्जर्व करते हैं तो ऐसा होता है कि हमारा जो टॉप है वो बॉटम में दिखे? नहीं, ऐसा कभी नहीं होता. हमारी इमेज हमेशा इरेक्ट होती है. That is virtual image and erect image. So if we, and virtual means the rays appear to meet. अब रेज जो हमारी इमेज बनती है उसकी रेज एक्चुअली मीट नहीं करती, बट ऐसा अपीयर करता है कि वो मीट होते हैं. सो इफ वी टॉक अबाउट द इमेज फॉर्म्ड इन द प्लेन मिरर, इट इज virtual and erect. So there were four options that what is the image formed by the plane mirror. Whenever we see, it is virtual and erect. Moving ahead to the next question. Okay, a concave mirror. We are basically talking about a concave mirror, and a concave mirror gives real, inverted and same sized image if the object is placed. अब अगर हम concave mirror की बात, the time is passing, yes. Where is, great. So if we are talking about the image is, see, as you can see, if we are talking about the concave mirror, the image is always formed is virtual, erect and enlarged. And if we look up in the case, where is the object placed to get the virtual, erect and enlarged image? The object is always placed between F and P. So when the object is placed between F and P, we get the image as virtual, erect and enlarged. So yes, the answer would be between F and P. Moving ahead to the next question. In optics, an object which has higher refractive index, जिस object का higher refractive index होता है, it is called what? उसे हम क्या बोलते हैं? Optically rarer, optically denser, optically density or refractive index. Out of these four, which will be the answer, or what do we call an object which has higher refractive index? Optically rarer, optically denser, optically density, refractive index. Hurry up, the time is passing. Yes, perfect. Great. It is called as optically denser. Optically denser बोलते हैं जिसमें higher refractive index placed होता है. Moving ahead to the next question. The radius of curvature of the mirror is 20 centimeter. Find the focal length. This is a very easy question and the answer must be there within some seconds. Radius of curvature is 20 centimeter. What is the focal length? Okay. What is the relation of the focal length and the radius of curvature? Perfect. Great. Very good. So if we talk about the relation between the radius of curvature and focal length, you can see the focal length is just half of the radius of curvature. So F is equals to R by 2. Since radius was 20 and if we'll divide 20 by 2, we will get what? We will get 10 centimeter. So our answer will be, which is the correct answer? That is 10 centimeter. Perfect. Moving ahead to the next question. Convex lens focus a real point-sized image at focus. Now we are talking about convex lens. और आपने जो इमेज नोटिस करी है वो कैसी है? रियल है, पॉइंट साइज है और फोकस पर है. आपको बताना है कि ऑब्जेक्ट कहाँ पे प्लेस हुआ. हरी अप. If we are talking about convex lens, where is the object placed? The time is passing. Hurry up. Yes. So perfect. As you can see in this ray diagram, which is there on your screen, the rays are coming from infinity. We do not know where the rays are coming from, whether from sun or where. Since we do not know the finite distance, so the object must be at infinity when the image is formed at focus. And through this image you can also conclude that convex lens is a converging lens. There are so many times it has been asked which lens is the converging lens. So since many rays are coming and meeting up at a single point, as you can see, so it is an example of a converging lens, and the rays are meeting up at focus, so the object must be at infinity. Moving ahead to the next question, power. Now, the power of the lens is -4 diopter. You need to tell me the focal length. The power of the lens is 4 diopter. You need to tell me the focal length. Hurry up. What is the relation between the power and the focal length? Which would be the correct answer? I could see perfect. Yes, if we talk about the relation between the power and the focal length, the relation is what? The power is equals to 1 upon focal length, and so if we have to find out focal length, it would be equal to 1 upon power. What is our power? The power is -4 diopter. So 1 upon -4 would be giving us -0.25 meter, and that's the perfect answer. So the correct answer would be what? It would be -0.25 meter. Great. The next one. Now, this is an interesting question and a good one as well. I think that you need to use your mind carefully. An object is placed 20 centimeter in front of a plane mirror. अब एक object 20 centimeter दूर है mirror से. The mirror is moved 2 centimeter towards the object. हमने mirror को object के पास shift कर दिया 2 centimeter. आपको क्या बताना है? See, this is a twisted form of the question that has been asked. The distance between the positions of the original and the final image seen in the mirror. आपको पहले की पोजीशन बतानी है जब वो 20 सेंटीमीटर पर था, फिर उसकी क्या नई पोजीशन हुई, और दोनों जो इमेज के गैप्स हैं आपको वो बताने हैं. Think the distance between the position of the original and final image. Where was the original image formed? Where is the final image formed, and the distance between them? Great. I could only see some correct answers. Hurry up, think about the concept. See, this question is all about understanding. If the distance, suppose our object is towards the side and the distance between the object is and the mirror, this is our mirror, is 20. So image will be somewhat after 20 centimeter of the mirror, क्योंकि हमें पता है the distance of object from the mirror is equal to the distance of image from the mirror. तो distance of object and image कितना हो गया इस केस में? The distance of object and image is what? It is 40. Now if we talk about the mirror has been moved 2 centimeter. पहले 20 था, अब मिरर को मूव कर दिया है 22 सेंटीमीटर. तो अब ऑब्जेक्ट और मिरर का कितना डिस्टेंस हुआ? 18. बिकॉज वाई 18? बिकॉज इट हैज बीन शिफ्टेड 2 centimeter. So the distance between the object and the mirror is 18. Now if we'll talk about the mirror and the image, image will be somewhat same at the 18 centimeter backwards. So if I talk about the distance between the object and the image in this case would be what? It would be 36. And the question is saying the distance between this case and this case. That means earlier when it was at 20 and afterwards when it is at 18. So the distance or the difference would be what? Would be 4 centimeter. So it's a simple question, but the language is somewhat twisted and so practice needs to be done. The answer of this particular question would be 4 centimeter. Moving ahead to the next question. This is again a different question turning out. A ray of light that strikes a plane mirror PQ at an angle of incidence of 30 degree. Now, one of the ray of light termed as PQ is getting incident at the mirror और वो angle बना रही है 30 degree. अब वो जो रे आई PQ वो रिफ्लेक्ट हुई और रिफ्लेक्ट दोबारा कहाँ पर हुई? प्लेन मिरर पर भी. तो प्लेन मिरर पर दूसरी इंसिडेंट रे आ गई जो पहले वाले की रिफ्लेक्टेड रे थी. नाउ द एंगल ऑफ रिफ्लेक्शन एट द सेकेंड मिरर इज, आपको फर्स्ट मिरर का नहीं बताना है, आपको सेकेंड रे का बताना है. हरी अप. ग्रेट दिव्या. Hurry up. See, you need to understand the concept carefully as the digits can be changed. As on your screen towards the left, you can see a diagram. You can even take up the screenshot of this question and you can see. देखो एक रे आई, जो रे पहले स्ट्राइक कर रही है मिरर PQ पर वो 30 डिग्री पर फॉल कर रही है. तो जब वो रे 30 डिग्री पर, ये हमारी AB जो रे है ये फर्स्ट रे है जो स्ट्राइक कर रही है हमारे PQ मिरर पर. तो इस केस में इसने कितना एंगल बनाया? 30 डिग्री. तो रिफ्लेक्टेड एंगल भी कितना हो गया? 30 डिग्री. बिकॉज वी नो एंगल ऑफ इंसिडेंस इज इक्वल्स टू एंगल ऑफ रिफ्लेक्शन in the case of laws of reflection and reflection. So now when this ray is falling to the surface, you can see by the alternate interior angle, if this angle is 30, this angle will also be 30, and if this is our normal, then the angle made by the second one would be 60 degree. क्योंकि अगर आप समझें, अगर ये हमारा सरफेस है और यहाँ पे एक रे आके स्ट्राइक कर रही है और वो रे जो एंगल बना रही है सरफेस के साथ वो कितना है? 30 डिग्री. वाई इट इज़ 30 डिग्री? आई होप इट इज़ क्लियर. बिकॉज हमारे पास ऐसा भी एक एंगल है और ये दोनों ऑल्टरनेट इंटीरियर एंगल्स हैं. सो दिस इज ऑल्सो 30 डिग्री. नाउ इफ आई विल ड्रॉ अ नॉर्मल, you can see this angle would be what? This angle would be 90 degree. Now since this is 30 degree, the leftover part would be what? The leftover part would be 60 degree. And since it is 60 degree, the angle of reflection would also be 60 degree. So the angle of reflection at the second mirror is, or a second case would be what? Would be 60 degree. So the answer would be 60 degree. Moving ahead to the next one. A concave mirror produces a magnification of +4. जो concave mirror है उसकी magnification +4 है. तो object कहाँ पे placed है? देखिए, think about it and then I'll explain what could be the answer and why. Think. Yes. So as you can see, first of all it is a concave mirror, and secondly the question is you get a magnification of +4. +4 मीन्स जो आपकी इमेज है, देखिए हम +4 से क्या कंक्लूड कर सकते हैं, ये भी आपका कभी क्वेश्चन आ सकता है. प्लस डिनोट्स व्हाट, दैट द इमेज इज व्हाट, वर्चुअल एंड इरेक्ट. एंड अगर हम 4 की बात करें, 4 मीन्स if it is greater than 1, that means the image is what, the image is enlarged. So if we have the virtual, erect and enlarged image, it is always placed between focus and pole. So you need to search, you need to think about the characteristics of image and then answer. So the correct answer is between focus and pole. Perfect. Great, students. Moving ahead to the next question. A ray of light passes from medium X to another medium Y. No refraction of light occurs if the ray of light hits the boundary of the medium Y at an angle of. तो एक रे है जो आ रही है मीडियम X से मीडियम Y में, और जब वो मीडियम X से मीडियम Y में आ रही है तो कोई रिफ्रैक्शन नहीं हो रही है. आपको बताना है what would be the angle. Hurry up. Yes. Great, students. Perfect. So if we discuss about this question, you need to remember a ray of light does not bend in two cases. कोई bending नहीं होती है जब two reasons होता है. There could be two reasons. First, when the angle of incidence is 90 डिग्री, जैसा कि आप इसमें देख सकते हैं. जब एक रे 90 डिग्री पर स्ट्राइक करती है तो वो कोई बेंडिंग शो नहीं करती, क्योंकि एंगल ऑफ इंसिडेंस कितना होता है इस केस में, 0. एंगल ऑफ इंसिडेंस 0 होता है क्योंकि वो 90 डिग्री पर ही फॉल कर रही है. 90 डिग्री पर ही हमारा नॉर्मल है, तो नॉर्मल और एंगल ऑफ इंसिडेंस के बीच में, इंसिडेंट रे के बीच में कोई एंगल ही नहीं फॉर्म हुआ. तो इस केस में it is the very first case when no refraction of light occurs when the ray of light hits the medium or the boundary of the medium at an angle of 90 degree. And the second is the case when both the mediums have same refractive index. When both the mediums will have same refractive index, then also no bending of light occurs. So the answer of this would be 90 degree. Perfect. Moving ahead to the next question. A lens of focal length 12 centimeter forms an erect image 3 times the size of the object. अब आपको focal length दी हुई है question में. It is given that the question is of lens and the image formed is 3 times the size of the object. You need to tell me what is the distance between the object and the image. Hurry up, think about it and let me know what is the distance between the object and the image. Hurry up. Come on, it can't be so fast. Hurry up, your time is about to end. Great. So, see, this question needs to be solved. It is given a focal length of 12 centimeter forms an erect image 3 times the size. So, we know that the erect image is formed in case of what? Convex and concave, both the lenses. But if it is 3 times, in case of concave lens, there are 2 ray diagrams in case of concave lens, and both the ray diagrams forms diminished image. So it cannot be 3 times. So basically the lens chosen would be what? The lens would be convex. Then only is it possible that we can get 3 times the size of the image, मतलब enlarged image. और enlarged image हमें किससे मिलती है? कॉन्वेक्स लेंस से मिलती है. तो जब हमारी enlarged image है और focal length कितनी है? see, focal length is 12 and we have decided that the lens is convex. Lens कैसे decide किया? Enlarged image देखकर, क्योंकि enlarged image सिर्फ हमारा convex lens देखता है. तो focal length plus 12 है, magnification plus 3 है. अब आपको क्या बताना है? You need to calculate again both the things. You do not have u, that is the distance of the object, and even you do not have v, that is the distance of image. So, but you know the formula of magnification. What is the formula of magnification of lenses? It is v upon u, and magnification is 3. So 3 is equals to v upon u, or v is equals to 3u. We got the relation between the distance of object and the distance of image. So if we will solve further, we got that v is equals to 3u. And now if we will place it in the lens formula, what is the lens formula? 1 upon f is equals to 1 upon v minus 1 upon u. And we know what we need to use. We need to write v as 3u. So 1 upon 3u minus 1 upon u would give us, is equal to what? 1 upon 12. So when we will solve it, we will get, by taking the LCM, minus 2 upon 3u is equal to 1 upon 12. And after solving, we will be getting, after cross multiplying, u is equals to minus 8 centimeter. Now, since u is minus 8, what is u? The u is the distance of the object from the mirror. We need to also find v. V is 3 times of u, as we have obtained the relation. 3 into minus 8 would give us what? Would give us minus 24. So if we are talking about the distance of the image, it would be minus 24 centimeter. But as asked in the question, you need to find out the distance between the object and the image. So what is the object? The object was denoted by u and the image was denoted by v. So putting up the required values, we will be getting the above relation, and after that minus 8 plus 24 will give us 16 centimeter. So if we are talking about this numerical, it is important and also asked in the boards last year. So you need to be careful while reading the question and answering it. So the correct answer is 16 centimeter. Moving ahead, we have a next question. This is also an interesting question and further a practical question as well. So you could see, while performing an experiment on determination of focal length of a convex lens, you could see that a convex lens experiment has been done by a student in the lab. 4 students obtained the image of the same distant tree on the screen. So you can see 4 students have observed the images and the readings are different. Which diagram shows the formation of image correctly? So you need to observe the images carefully. There are 4 options and hence your time starts now. Think about the correct option and let me know which is the correct diagram observed by the student out of these 4. Great. So as you can see the 4 figures, in all the 4 cases you need to observe the image and you have to tell which is the correct case. They all meet at focus, and if the image is formed at focus, and especially in case of convex lens, as it is clearly observed that the lens is the convex lens. So in case of convex lens, the rays which are coming from infinity will meet at focus, and when it will meet at focus, a well illuminated tree can be seen on the white thick board. And how can you say the correct answer? By looking at the image. In case of B, many are answering B. The B is the virtual and erect image. I hope you all know what do we understand by virtual and erect. अगर हमारा object क्या टॉप और हमारी इमेज का टॉप दोनों सेम हो, इट इज वर्चुअल एंड इरेक्ट. बट अगर हमें इन्वर्टेड दिख रहा है, दैट मीन्स टॉप will come to the bottom and bottom will come to the front. It is real and inverted. And we all have studied in the ray diagrams that the convex lens always form real and inverted. So the correct observation would be D. So be careful while solving these type of questions. Moving ahead, this is also an interesting question or a numerical. A 10 millimeter long awl pin is placed vertically in front of a concave mirror. A 5 millimeter long image of the awl pin is formed at 30 centimeter in front of the mirror. You need to find the focal length. Now the object is the 10-meter long awl pin, and when it is observed in case of concave mirror, it has turned 5, means the size has reduced. Now you need to tell what is the focal length in this case. Hurry up, time is passing. Great. See, if we talk about this, you all know in this particular question, a 10 millimeter long pin. So 10 millimeter is the height of object. If we are talking about what is the height of object, the height of object is 10 millimeter. And the height of image is what? The height of image is 5 millimeter. So it is obvious that the size has been reduced. And from this, if I'll try to find out the formula of magnification, we know it is height of image upon height of object. And if I'll put 10 upon 5, I'll get 2. Height of image, the height of object. So it would be what? 5 upon 10. If I particularly talk, it would be 5 upon 10 and hence 1 upon 2. So if magnification is 1 upon 2, the size has been diminished. And if the size has been diminished, we need to find out the focal length. And for that, you need to know what is given. That the image of the awl pin is formed at 30 centimeter in front of the mirror. That means image distance is given. And we all know that the image distance is denoted by V. So V is what? Minus 30. And again with the formula of magnification, what is the formula of magnification? In case of mirror, it is minus V upon U. V is already minus 30. Putting magnification is 1 upon 2. You will get U as minus 60 centimeter. So now we are having V and U. Putting up the desired values in the case of the mirror formula, 1 upon F is equals to 1 upon V plus 1 upon U, you will get your focal length. So what is V? V is minus 1 upon 30 and U is always negative, so minus 1 upon 60. When you will be solving, the focal length would be turning out to be, yes, minus 20. So you can take out the LCM and solve it out. You will be getting the focal length as minus 20. So among the options, which would be the correct one? The second one. Be careful while solving the questions. They are important and have been a part of your syllabus. Okay, the next one. A light ray enters from medium A to medium B. As you can see towards the right, there is a picture and the light ray is traveling from medium A to medium B. The refractive index of medium B relative to A will be. आपको लाइट शोकेस करी हुई है A से B की, आपको बताना है refractive index medium B का with relative to medium A. So, hurry up, observe the figure carefully and answer. The time is passing by. Yes. So time's up. Let's understand what the question is saying. A light ray is traveling from medium A to medium B. When you will observe this light ray carefully, when it is going from medium A to medium B, see, it is clearly observed when light rays is going from medium A to medium B, it is bending towards the normal. ये हमारी normal है और वो normal के पास आ रहा है. So when the light ray bends towards the normal, which means that the medium B has higher refractive index, क्योंकि हमें पता है जब वो रेयरर से डेंसर जाते हैं तभी बेंड होता है टूवर्ड्स द नॉर्मल, एंड denser means higher refractive index, so it is bending towards the normal, and so that means the speed of light is less in case of medium A. So if we are talking about refractive index of medium B with respect to A, what it would be? Yes, it would be greater than unity. Unity means 1. Since it is denser, so the answer would be greater than unity. Moving ahead to the next question. Beams of light are incident through the holes. Now you can see there are two holes A and B, and the beams of light are incident on this, and they emerge out of the box through the holes C and D. So the light rays are coming out from C and D holes and they are moving in from A and B, as you can see it in the figure. Which of the following could be placed inside the box? Now you need to tell, as per your understanding, which among the four would be inside the box. A rectangular glass slab, a convex lens, a concave lens, or a prism. Hurry up, hurry up. Okay, the time's up. You need to have a look upon the diagram carefully. See, if it would have been a convex lens, the rays would have gone and meet up at a single point because it acts as a converging lens. On the other hand, if it would have been a concave lens, the rays would have passed and diverged. So if the rays would have diverged, it would have been concave. If it would have been converged, it would be convex. Since they are showing bending, and bending of light is observed in case of what? Yes, in case of rectangular glass slab. So the apparatus inside the box or the instrument inside the box would be rectangular glass slab. Next, the diagram showing the correct path of the ray after passing through the, you need to hurry up and tell me, in among the four figures, which figure is showing the correct path of the ray diagram? The last second question of today's series. Which among the following is showing the correct path? There can be more than one. Hurry up. Answer as per the Roman numeral in this picture. Very good, great. Yes. If we will observe the picture carefully, this is our optical center, and we know that the ray of light passing through optical center goes undeviated. So this is correct. The second one, when the ray of light is parallel to the principal axis, it will pass through focus. So this is also correct. The third one is when the ray of light is passes through the focus, it becomes parallel to the principal axis. So the third one is also correct, and the fourth one is wrong. So which all are the correct path? The answer would be all the three, first, second and third as well. The last one. Neat. This is an interesting question. A child is standing in front of a mirror or a magic mirror, and she finds the image of her head bigger. So now her head is seen bigger than the normal head, and the middle portion of her body is of the same size. And if we'll talk about the legs turned small. So the following is the order of the combination for the magic mirror from the top. You need to tell कि उसने क्या ऑब्जर्व किया, अपने हेड को कंपेरेटिवली बड़े साइज में ऑब्जर्व किया, जो मिडिल पोर्शन था वो सेम साइज का ही रहा, और जो लेग्स थी वो और भी स्मॉल हो गई. तो वो एक मैजिक मिरर था, और क्या क्या कॉम्बिनेशंस लगाकर वो मैजिक मिरर क्रिएट हुआ होगा. दिस इज द लास्ट क्वेश्चन ऑफ टुडेज सेशन. हरी अप. Great. Yes. So the time's up. See, the top portion, if you're talking about the top portion, since the head is found to be bigger, so the mirror responsible for giving the enlarged image is none other than concave mirror. You can also see it on this image. तो जो हेड है वो हमारा बिगर साइज में नोटिस हो रहा है. सो बिगर साइज में कौन सा मिरर हमें इमेज देता है? हमें हमारा कॉनकेव मिरर देता है. सो द टॉप वुड बी कॉनकेव मिरर giving us the same the bigger size. If the middle body is of the same size, we know that the plane mirror or the mirror which we use in our normal day-to-day life shows us the same size images, and the legs are found to be diminished and the size gets reduced in case of convex. So in this would be the pattern: concave, plane and convex, and all the images would be virtual and erect. Remember, none of the images formed is inverted. So the answer of this question would be concave, plane and convex. Moving ahead, thanks for joining the session. Meet you in the next class. Take care, have a good day, be safe.